Hello and welcome to our today's lesson. This is chemistry online teaching learning process. This week was about celebrations of Orthodox Christmas. So I was late there. I didn't make some learning teaching process during this time because it was too much crowded in our culture. Now I'm coming with today's lesson, but before I have our today's lesson, let me take you back what we have said in last discussion that was about chemical property. One part of chemical property that is like a terminalization when three volume or three molecules of acetylene with high temperature changes to directly to benzene. This process we call it terminalization process, where with high temperature from 600 up to 700 with the three molecule of the same molecule, that is acetylene, carbon-carbon triple bond, where we make with high temperature we have yields of products that is benzene. Now we are going to talk about preparation of alkane. Preparation of alkanes are, alkanes they have preparation in industrial process as well as in laboratory process. So from this we have a preparation of alkane, as we have so in our last discussion. Preparation and chemical properties are quite different things. If we are talking about preparation, how to make preparing this triple bond, but during chemical properties, our raw materials are most of the time this triple bonds. But here, our result, our product is always a triple bond. But what are the necessary steps to producing triple bond or alkane? You see, so let me start from the first. There are a lot of chemical reactions that could be producing triple bond, but from them we have two important steps how to make prepare alkanes in laboratory. Dehydrohalogenation of vicinal halide. Vicinal halide means dehydration means there is a removal of two things here. One is halogen group and the second one is water. Dehalogenation. When we talk about the halogen of vicinal halide means with a presence of a catalyst as a reagent like base, they producing triple bond or alkyne. Look, here we have a general formula RCH plus sodium hydroxide. Our result is R is just for alkyne and C triple bond CH plus sodium X. Sodium X stands for halogen family, and this is water. So this one is alkane. Our general terms is how to producing alkane or triple bonds from the given molecules. Therefore, R stands for alkyl group and XX for halogen families. This we call it vicinal dihalide. Vicinal dihalide. If there is here, look, let's come to the specific property of this chemical equation. CH3, CH, now CH3 means for R, stands for R, and CH3 chlorine. And also here we have a chlorine plus 2 molecule of potassium hydroxide. Our result is CH3, CH3 is alkali instead of R, and CH3 double bond, CH, this is we call it propane. Here we have the three carbon atoms, therefore we can say propane and potassium chloride plus water. This is a short notice how to make preparing alkane. Look, this one is a short note which standard how to preparing alkane. Now also we have 2 and 3. When we name this chemical equations are 1, 2 hyphen dichloropropane. This is the initial product, the initial reactant, and with base reagents plus water. As we have said, dihydrohalogenated means the removing of this hydrogen, water and halogen forms. Therefore, they are removed from our equation. And the second one is alkalination of sodium acetyl halide with a primary alkali halides. Here we have iron form, sodium cyanide, alkylation of sodium acetylene with primary alkali halides. HC, triple bond, C minus, N plus. This is as a form of iron, complex iron. Then RX plus H, carbon triple bond. This one is R as a general form, and NX. This is the salt. Sodium carbide. Its name is sodium carbide with a primary alkyl halides. Let's come this as a general, but here we have a specific one. This is sodium carbide plus CH3, Cl, and our result is H triple bond CH3 plus sodium chloride. This is what? Alkane. This one is a triple bond. This one is sodium chloride. Next, let's see about cycloalkanes. Cycloalkane have a general formula of CnH2n minus of 4. This is CnH2n minus of 4. N starts from 2 as usual. Then most of the time, these cycloalkanes are so complex. They always starts from 4. Cyclooctane is the simplest cycloalkanes that is stable compounds. Look, here we have C8, H12. Its a general formula. Its structural form is cyclooctane. Look, here we have a triple bond. This is the simplest one. And last, we have use of alkane or acetylene. Most of the time, this common name of alkanes are acetylene. For cutting and welding material is used auxiliary torch with high temperature around 300 degrees centigrade, used for cutting and welding for metals. And acetylene is also used for making vinyl chloride and vinyl cyanide, and to make primary acrolein. Different products like acrolein will be producing using this acetylene. And producing this acrylonitrile, raw material for textile fibers, vinyl chloride, which is used for polymer to give polyvinyl acids like PVC. PVC is a common one, which is preparing in industrial processes, not in laboratory. Commonly used for making floor tiles and electrical insulators, shoe soles, water pipes, and acetylene also used that serves as a solvent for waxy, greaser, and rubber. This is an example of use of acetylene or alkanes. It may be in laboratory or it may be industrial based for large productions. This is enough for today. Next we are going to see about aromatic hydrocarbons. This is enough. Open hydrocarbons are already including this like alkane, carbon-carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. That means when we make categorize saturated and unsaturated hydrocarbon. But next we are going to see aromatic hydrocarbon. Somehow it's different from this. From the saturated hydrocarbons or from the open chain carbon hydrocarbons are different. It's aromatic hydrocarbons. Enough for today. Thank you very much for watching me, and I hope you will see you'll understand me if you make join in my Telegram channel and YouTube channel. Thank you.